Section 5.3 deals with polynomials and polynomial functions. And these are things that you should have been introduced to before, but we'll go ahead and do some basic definitions. So first of all, a term is the product or quotient of numbers and or variables raised to powers. And just as a note, a term can be a number all by itself, like 5, or a variable all by itself, like x, but more commonly it's the product of numbers and variables, and those variables are often raised to powers, such as 4y squared, or negative 2xy cubed, 1/2 ab, and 3x squared yz. So these are all examples of terms. And a term is a really basic concept in mathematics. We see terms all the time in expressions and equations. And the basic anatomy of a term is that you have some number called the coefficient multiplied by some variable, often x, but not always x, and then raised to some power. And this power here is the degree of the term, and so this is what we would call a third degree term. Okay, let's go on to talk about polynomials. So the definition of a polynomial is that it is a single term or the sum of terms in which all variables have whole number exponents. Also, no variables appear in the denominator. So a polynomial is basically when you add a bunch of terms together and all of the terms have whole number exponents. So you cannot have fraction exponents, you cannot have negative exponents. So our first example of a polynomial here is 5x plus 2. So 5x by itself is a term and 2 by itself is a term. And this polynomial has two terms and is referred to as a binomial. So the word binomial means a polynomial with two terms. The next example, x squared minus 3x minus 10. This is a three-term polynomial, which we call a trinomial. Next example, x to the third power plus 4x squared minus 4x minus 16. This is a four-term polynomial. We don't have a special name for four terms. And our last example, going back to a simple example, 4x cubed all by itself is what we would call a monomial, which just means a polynomial that only has one term. The basic anatomy of a polynomial, if we just look at this particular example, 3x squared plus 5x minus 7. First of all, most of the time we will write our polynomials in what we call descending order. That means the powers go from highest to lowest. And it's worth noting here that the number negative 7 on the end, you can think of that as negative 7 times x to the 0. And if you put the first degree power on the x there, you can see how the powers decrease from highest to lowest. And this is what we mean when we say it's written in descending order. When it's in descending order, the first power of the variable that you see is the degree of the polynomial. And so this is a second degree polynomial. This polynomial has three coefficients, and those coefficients are 3, 5, and negative 7. And the leading coefficient is defined as the coefficient of the highest degree term. And if it's written in descending order, the leading coefficient is the first number that you see, which is where it gets its name from. And finally, the constant on the end of the polynomial, again, if it's in descending order, that constant is what we call the constant term. So in this problem, negative 7 is the constant term. Now let's talk about polynomial functions. A polynomial function is when you have a function, such as f of x, defined as a polynomial expression. And so I have three polynomial functions defined here. I won't read them off, but we have a second degree polynomial here, a third degree polynomial here, and another second degree polynomial here. We evaluate polynomial functions just like we evaluate any other type of function that we've done previously. So for example, if we're asked to do f of negative 3, we're going to take negative 3 and replace x with negative 3 in the function f of x. So this becomes 3 times negative 3 squared plus 4 times negative 3 minus 10. Now it's important to remember order of operation. So first we should do exponents. So negative 3 to the second power is positive 9. And so this becomes 3 times 9 plus 4 times negative 3 minus 10. And then if we just do the math here, 3 times 9 is 27. 4 times negative 3 is negative 12, and minus 10. And 27 minus 12 is 15, and 15 minus 10 is 5. And so the function value here, f of negative 3, is equal to 5. And so let's just remind ourselves, when we say f of negative 3 is equal to 5, remember that negative 3 is your x value and 5 is like your y value. How about g of 2? So to calculate g of 2, we have to go to the g function, and we're going to replace x with 2. And so if we do that, we get 2 to the third power plus 2 times 2 times 2 to the second power minus 6. So again, I'm just taking 2 and replacing x with 2 here and replacing x with 2 here. Again, order of operation, do the exponents first. 2 to the third power is 8 plus 2 times, and 2 squared is 4. And so this becomes 8 plus 8 minus 6, which is equal to 10. Okay, and finally, h of negative 5. For this one, we go to the h function, and we're going to replace x with negative 5. Make sure when you put a negative value into a function that you always use parentheses when you do that. So when you put negative 5 in for x, make sure you write that as the quantity negative 5 squared minus 25. And this is 25 minus 25, which is 0. Okay, so our next example is an application of polynomials. Let's suppose the polynomial function h of t equals negative 16 times t squared plus 128 times t. Let that represent the height of a rocket in feet after t seconds. And so if you're wondering why we use h of t, in this case, h stands for height, so it kind of makes sense. Let's find the height of the rocket after 2 seconds and 6.4 seconds. Now remember, t is the time. And so when t equals 2 seconds, the height at that particular time is given by plugging the value of t into the function. So we're going to do h of 2. H of 2 means we take the number 2 and we put it in for t into this function. And so doing that gives us negative 16 times 2 squared plus 128 times 2. And if we do the math here, this is negative 16 times 4 plus 128 times 2 is 256. And negative 16 times 4 is negative 64. Plus 256. And this is equal to 192. And this is feet. And so this means 2 seconds after the rocket is launched into the air, its height will be 192 feet. So the next part of this question is to do the same thing after 6.4 seconds. So for this, we have t equals 6.4 seconds, and the height at this time will be h of 6.4, which means we need to plug 6.4 into our polynomial. And to do this, I think it's best to use a calculator. So 6.4 to the second power is equal to 40.96, and 128 times 6.4 is equal to 819.2. Next, we'll multiply negative 16 times 40.96. And when you do those calculations, you get negative 655.36 plus 819.2. And if we add 819.2, we get 163.84 feet. So, after 6.4 seconds, the height is actually lower than 2 seconds. So, how can that be? So, let's go ahead and look at the graph of this function, just so we can bring some context into what we just did. So, let's insert the graph here. Now, looking at the graph, you can see that this function is time on the horizontal axis and height on the vertical axis. So let me go ahead and label that. We have time here, and we have height up here. So we said after 2 seconds, the height was 192 feet. Here's 2 seconds, and you can actually plot the point. That's how high it is, and that number corresponds to 192 feet. Now at 6.4 seconds, 6.4 is right about here, and the height at 6.4 you can see is somewhere in here. And that height corresponds to 163.84. So the reason the height is lower after 6.4 seconds is because the rocket is shot into the air, reaches its highest point, and then begins to come down. And you can actually see from the graph that the rocket will come back down to the ground at 8 seconds. Moreover, from the graph you can see that at 4 seconds it will reach its maximum height, which is somewhere in between 200 and 300 feet. We'll talk more about these kinds of things later on in this class. Okay, the final concept for this section is adding and subtracting polynomials. Basically, adding and subtracting polynomials is relatively simple. What you need to do is you need to combine like terms. And so when we're adding this 4th degree polynomial to this 4th degree polynomial, we just need to add the coefficients in front of the like terms. Now to do this, you can reorder the terms if you want, but it isn't completely necessary to do that. But if you want, you can reorder the terms, removing the parentheses. So we have 3x to the 4th plus negative x to the 4th. So that would be minus x to the 4th. And then we have minus 5x cubed here. And we have positive 2x cubed there. Next we have positive x squared here. And notice that there aren't any x squareds in this other polynomial, so that's all by itself. And then we have over here plus negative x. So I'm going to write that term next. And then finally we have minus 2 and positive 10. And what we're going to do now is combine the like terms. And so 3x to the fourth minus 1x to the fourth is 2x to the fourth. Negative 5x cubed plus 2x cubed is negative 3x cubed. Then we have positive x squared and negative x. And finally, negative 2 plus 10 is positive 8. So adding polynomials is simply a matter of combining like terms. Subtracting polynomials is essentially the same idea, except that when you subtract, you have to distribute the negative sign. And so subtracting here, we have the first polynomial, which remains unchanged. And then when you subtract negative x to the fourth, you get positive x to the fourth. When you subtract positive 2x cubed, you get negative 2x cubed. Subtracting negative x gives us positive x. And finally, subtracting positive 10 gives us negative 10. And then we're going to combine like terms once again. This time, I'm not going to reorder the terms. I'm going to leave it like this. And I'll just underline the like terms. So 3x to the fourth is a like term with 1x to the fourth. And when we add those together, we get 4x to the fourth. Next, we have negative 5x cubed and negative 2x cubed. That is negative 7x cubed. Plus x squared is the only x squared term. Plus x is the only x term. And finally, we have negative 2 and negative 10, which combine to make negative 12. So adding and subtracting polynomials is just a matter of combining like terms. So that's it for 5.3, but we're going to go ahead and move right on to 5.4. And in this section, we talk about multiplying polynomials. Now, multiplying polynomials will use properties of exponents. So for example, when we multiply these two together, we're going to multiply x squared times x to the fourth. And to do that, we add the exponents. And we also need to multiply the coefficients. So we'll be using some properties of exponents. And in later examples, we will also be using the distributive property. But you've used these properties before, so this shouldn't be too big of a deal here. So when multiplying monomials together, we are simply going to multiply the coefficients. And so 3 times negative 2 is negative 6. And then we have x squared times x to the fourth. And this is going to give us negative 6x to the 2 plus 4, which is negative 6x to the 6th power. Now, once you know what you're doing here, you don't have to show all these steps. So I'm showing them to you so that you can see what's happening. In our next example, we're going to use the distributive property. So when we distribute, we get 3x multiplied by 2x plus 3x multiplied by 4. 3x times 2x, remember that's 3x to the 1 times 2x to the 1. So 3 times 2 is 6, and x to the 1 times x to the 1 is x to the 1 plus 1, which is x squared. And then 3x times 4 is simply 12x. So we'll be using distributive property and also properties of exponents, as I've mentioned. Okay, so moving on here, the next example is very similar. We're going to distribute negative t to each one of those. Negative t times t squared is negative t cubed. Negative t times 8t is negative 8t squared. So again, if you're a little bit confused here, remember the power here is 1 and the power here is 1. So we're just adding powers. And then finally we have negative t times negative 5. That's going to be positive 5t. And our final example on this slide is what do you do with a polynomial when you just have a negative sign in front of it? Well, it's very much like our subtraction example. You can remind yourself that a negative sign is really like negative 1. And so what you're doing is you're multiplying all of these by negative 1. But when you do that, all it does is change the signs of each of the terms. And so this is what we should end up with here. Now, example 5 is pretty much the same as our previous examples. The only reason I bring up example 5 is because sometimes you will be multiplying a polynomial by a monomial, but it'll be on the right-hand side instead of the left-hand side. And this doesn't matter. We can still distribute 2x like this. We can actually distribute from either side. So if we do that, we have 2x multiplied by 3x squared minus 2x multiplied by 4x, and then plus 2x multiplied by 1. So I'm just multiplying each one of these by 2x. And if we do that multiplication, we end up with 6x to the third power minus 8x to the second power plus 2x. Now, example number 6 should look really familiar if you remember taking elementary algebra. We're multiplying two binomials together, and when we do this, we need to make sure that every term in the first polynomial gets multiplied by every term in the second polynomial. And one way to ensure this is to draw arrows. So we're going to take 4x and multiply it by 3x, and 4x and multiply it by negative 5. And then we'll take 2 and multiply it to 3x, and 2 multiplied to negative 5. And sometimes this procedure is referred to as the FOIL process. FOIL is an acronym. F stands for first, meaning that we're multiplying the first terms together. O stands for outside, meaning that we're multiplying the outside terms together. I stands for inside, so we're multiplying the inside terms together. And L stands for last, which means we're multiplying the last terms together. You don't need to think of this in terms of FOIL. All you have to do is make sure every term of the first polynomial multiplies to every term of the second. And so what we have here is 4x multiplied by 3x. That's this times this. And then we have 4x times negative 5. So I can say plus 4x times negative 5 plus the next one is 2 times 3x. And finally we have 2 times negative 5. And you notice that I chose to add every time. Don't worry too much about that. The negatives will come out when you do the multiplication. So 4x times 3x, that's 12x squared. 4x times negative 5 is negative 20x. 2 times 3x is positive 6x. And 2 times negative 5 is negative 10. And we have some like terms here in the middle that we can combine together. And when we combine those together, we end up getting 12x squared minus 14x minus 10. Example 7 is just like example 6, except that I've introduced some fractions. And so we're going to multiply very much in the same way. And of course, you don't have to write everything down when you're doing this. but I will do this just to make sure you understand. So we start with 6x times 6x, and then 6x times negative 1/2, and next is 1/3 times 6x, and finally positive 1/3 times negative 1/2, so we'll say plus 1/3 times negative 1/2. Now doing the math, 6x times 6x is 36x squared. 6x times negative 1/2, multiply the numbers. 6 times negative 1/2 is negative 3, and the x just comes down. Next we have 1/3 times 6x, that should be positive 2x. And finally, 1/3 times negative 1/2 is negative 1/6. And so combining like terms in the middle here gives us 36x squared minus x minus 1/6. Okay, next up we have a binomial multiplied with a trinomial. This pretty much works the same way. We just need to make sure that the first term of the binomial gets multiplied to each of the terms of the trinomial, and then the second term of the binomial multiplies to each term of the trinomial. And so when we do this, we get x times 3x squared plus x times negative 5x plus x times 4. So that's what we get when we multiply x times each of these. And then we have negative 2 times each of those. So we have negative 2 times 3x squared, negative 2 times negative 5x, and negative 2 times 4. And one thing I hope that you notice is that in each of these examples, I've used different notation for the multiplication. And so up here, I just put parentheses around one, but not the other. Here, I put parentheses around both. And down here, I'm using a combination of parentheses and dots. And I'm not trying to confuse anybody, but I want you to understand that there are various types of notations that you can use. Personally, I think using parentheses around everything is probably the safest way to do it, but I didn't want to make you feel like you had to do it that way every single time. So, what's x times 3x squared? Well, that'll be 3x cubed. X times negative 5x will be negative 5x squared. Positive x times 4 is positive 4x. So we did these three terms. Now we have negative 2 times 3x squared. It's negative 6x squared. Negative 2 times negative 5x is positive 10x. And negative 2 times positive 4 is negative 8. So here's our answer, but we need to combine like terms. And we have like terms here, and we have like terms here. And our final answer should be written in descending order. So combining like terms, we should get 3x cubed minus 11x squared plus 14x minus 8. All right, let's try a couple more. So on our last slide here, we have some special multiplication. And it's not really that special, to be completely honest. But when you have a binomial raised to the second power, we need to remind ourselves that this means we multiply that binomial by itself. That's the definition of squaring something. And so I'm going to skip some steps here. 3x times 3x is 9x squared. 3x times 2y Well, 3 times 2 is 6, and x times y is xy. 2y times 3x, that's also positive 6xy. And finally, 2y times 2y is positive 4y squared. And again, you can combine like terms in the middle here, and you end up with 9x squared plus 12xy plus 4y squared. Example 10 is very similar. So a minus 3b to the second power means a minus 3b times a minus 3b. A times a is a squared. A times negative 3b is negative 3ab. So anytime you do the product of two variables together, you should probably put them in alphabetical order. Negative 3b times positive a is negative 3ab. And finally, negative 3b times negative 3b is positive 9b squared. And if we combine the like terms in the middle here, we get minus 6ab. And so here is our final answer. Number 11 is a little bit different. In number 11, notice that you have two factors that appear to be similar, but not exactly the same. And that's because they have different signs in the middle here. So we approach this the same way. Doing the multiplication, 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Positive 4 times 3x is positive 12x. And finally, positive 4 times negative 4 is negative 16. Once again, we can combine like terms in the middle. And notice this time that the negative 12x and the positive 12x cancel each other out. And so we end up with 9x squared minus 16. Now, I said that these were special examples of factoring, so let me go ahead and give you some vocabulary here. In examples 9 and 10, we're looking at the perfect square trinomial situation. And that's because these trinomial answers that we got here came from a perfect square. We were squaring a binomial. And in number 11, our answer is the difference of two squares. And so this is called the difference of two squares. Multiplication. Okay, so moving on to example 12. This is special because what we have here is the product of three polynomials. We have a monomial multiplied by a binomial multiplied by another binomial. Now, when you're multiplying three polynomials together, you start by just multiplying two of them together. And the way I like to do this is I'll start with multiplying the binomials together. So I'm going to save the 3t, and then I'm going to work on multiplying these two together. So when we do the multiplication, 4t times 2t is 8t squared. 4t times negative 3 is negative 12t. Positive 5 times 2t is positive 10t. And positive 5 times negative 3 is negative 15. From there, we can combine like terms in the middle here. These two are like terms. Negative 12t plus 10t is negative 2t. And then once we have this completely simplified, like we do here, now I can distribute 3t multiplied to each one of those. And so 3t times 8t squared is 24t cubed. 3t times negative 2t is negative 6t squared. and 3t times negative 5 is negative 15t. So the key here is multiply two of them together and then multiply by the third one. You do not multiply all three at the same time. Now, number 13 is a lot like number 9 and 10, except that we have a higher power here. Just wanted to expose you to this. So 6a squared plus 5, quantity squared just means 6a squared plus 5 times 6a squared plus 5. And we're going to multiply this out. And so when we do that multiplication, 6a squared times 6a squared is 36a to the fourth. So remember, you are adding those powers together. And then 6a squared times positive 5 is positive 30a squared. And 6a squared times positive 5 again is positive 30a squared. And positive 5 times positive 5 is positive 25. And once again, combining like terms in the middle, we end up with this polynomial. So that concludes these two sections. Hopefully a lot of this stuff is review from algebra. Time to get to work.